All right, so for example,
Action.
if you were asked to find the antiderivative of 2x times the square root of 1 plus x squared, keyword there is times, you would not be able to do that. All the ones that we've done before, you could break them down into two separate things or something like that, but since this has multiplication, you're sort of trying to do somehow the reverse of the product rule, right? Which is just going to be, all right? And so to find this integral or to find this antiderivative, we use the problem-solving strategy of introducing something extra. And so what we're going to do is we are going to make a substitution to simplify this problem into something that we can do, okay? And so
That's the name of the strategy.
introducing something extra, yeah. And it begins.
I'm already.
Okay, and so when we first do these problems together, so for your assignment today, the first, I don't know, 10 of them or so, tell you what the substitution is that you're going to make, okay? But eventually you need to get to the point where you can figure out what the substitution is without someone telling you. But what we're going to do to start with is we're going to let u equal 1 plus x squared randomly, okay? And the reason why we're doing that is because that simplifies considerably. The square root of 1 plus x squared now becomes just the square root of u. Okay?
But then at the end you have to put it back.
Right, but there's more work for us to do in between now and then because we still have a 2x and we still have a dx, and we need to relate those things somehow to the u substitution that we have made, okay? And so here's how this goes. We're going to look at this and we're going to say, okay, the complicated part is the 1 plus x squared, so I'm going to let that equal u. So u equals 1 plus x squared, okay? Now, if I take the derivative of that, what's the derivative of 1 plus x squared? 2x dx. And conveniently, 2x dx is exactly what we have left. Okay? So the square root of 1 plus x squared now becomes the square root of u, and the 2x dx becomes du, and now we have a very easy antiderivative. Yeah, because it's the calculus book, so they'll set it up that way. Okay? Sometimes it's more complicated to figure it out. Sometimes you'll say, okay, I would like u to equal tangent of x or something, and then you take the derivative, and it doesn't match. And so you have to make a different guess for the u. But generally speaking, they're set up pretty straightforward, where when you make a u substitution and then you take the derivative of that, this matches up fairly nicely with what you have left. Okay? So now what we do is we solve the problem, what is the antiderivative of u to the 1/2 du?
Why is it 2x dx? Where did you
Because we're using the chain rule, and anytime you take the derivative of a variable, you go dx or dy or du or dt. Or
why are we doing chain?
we always are. Just usually we would say that dx is just equal to 1, so we don't need it. But now since we have a dx in the problem, we kind of need that piece. Okay. Okay. What's the antiderivative of u to the 1/2? Okay, so we add 1 to the exponent, so that gives us u to the 3/2 over 3/2. This is an indefinite integral, so we need to add a c onto there. Okay, then dividing by, what's that?
This is the anti.
Yeah, so the antiderivative of u to the 1/2 du is u to the 3/2 over 3/2. Okay, and then
yeah, you're having the integral equals that.
Right.
The integral of that equals that.
So
after
after we do this one, we're
okay,
doing another one.
yeah, oh, we'll do a number of them, yeah. And then dividing by 3/2 is the same as timesing by 2/3. So I'm going to say this is 2/3 u to the 3/2 plus c. And then like Abby said, or somebody said right at the beginning, we have to substitute that back in for our final answer. So our final answer is 2/3 times 1 plus x squared plus, to the 3 halves, sorry, plus c. Okay? So what I'm telling you is, if you took the derivative of this, if you took the derivative of 2/3 times 1 plus x squared to the 3 halves, you would get 2x plus or times the square root of 1 plus x squared. Okay? Hateful, yes.
When would this come up? Like if I'm walking in the park and I stumble across something, how would I know to do the substitution?
It comes up when, that's a good question. It's sort of like when you are solving a quadratic equation, okay? You have lots of different tools for that, right? You can graph it, you can factor it, you can complete the square, or you can use the quadratic formula, like say. Right, it's a tool to solve an integral, and so when I look at a quadratic formula that or equation that I need to solve, my first hope is, can I factor it? Because that's the easiest thing to do. Okay? So when you come across an integral, your first hope is, can I just like use the power rule or use my little note card to figure out what the antiderivative is? Okay? And if you can, then do that. But if you can't, the next tool that you try would be substitution. Okay? Sort of like sometimes you have a quadratic equation that you can't factor, so you go, crap, I need to use the quadratic formula. I don't like to do that. This is more difficult, right, than just factoring, but I can do it. Same deal here. Okay? So always look to see, can I do it an easy way first? That's just proving that the thing is the thing. All right? Okay, so let's do another one.
Okay, wait.
Yeah, the font in the, this is the only one of my textbooks that's not online, so I have to cut it up in pieces and then make it a PDF. PFDs and then PDFs, sorry, PDFs, PDFs, PFDs.
Great show.
Okay, so never mind all that. What do you think your U substitution would like? Well, first let's say what Gabe did. Do you think you can find the antiderivative of all that nonsense? No, probably not. Okay. So we're going to make a U substitution. What do you think, what's your guess?
Get rid of the
Cosine.
You want
Cosine x to the 4th plus 2. Can you do that?
No, and here's the reason why. Let me explain why that won't work. Because if I did let U equal this, and don't copy this down because this is wrong, then I would need to figure out what du is. And the derivative of this would be negative sine x to the 4th plus 2 times 4x cubed. Well, there's no sign in the original problem. So I would not be able to make that substitution. Does that make sense? So you need to let your U substitution be equal to something that if you take the derivative of it, that derivative is already in the problem. Okay? Right, and so it's just going to be x to the 4th plus 2, because if you take the derivative of x to the 4th plus 2, what do you get? 4x cubed dx. Now, we have an x cubed and a dx in there, but we don't have a 4. So how can I get rid of this 4? Right, I'm going to divide both sides by 4. And Pua, if you're watching this now, I know you're going, oh my gosh.
Hold on.
What is this witchcraft that he is doing? No, because if I took the derivative of x to the 3rd, then I would get 3x squared, and there's no x squared in there for me to use for that. And your clue is kind of,
Why did you talk about 4?
because what I have in my original problem is an x cubed dx. So I need to make this equal x cubed dx, okay? All right, so now, let's use a different color for emphasis. The x to the 4th plus 2 is this piece right here, okay? So that's going to be the cosine of u. And then the x cubed dx is this and this right here. So that's going to be du over 4.
I don't understand.
Okay, never mind, because we know how to take the derivative.
Why did you get cosine u?
Because I let x to the 4th plus 2 equal u. And so I just substituted this u in there for that. And now I have an integral that I can solve.
I've actually solved it with your power.
It's right here.
What do you do with the d over 4? Do you just leave it like that?
So you
I
don't
might actually put it in.
So, Rita says, what do I do with the du over 4? And since the du over 4 is like just times 1/4, I'm going to just pull that out. And put it like that.
Like this.
She's solving it over and
Right. So what's the antiderivative of cosine?
Stop.
Screw you for even asking. Okay, so that's going to be sine of u plus c. Of course you know cosine.
I know that, but I'm also, when you did get to that.
Yeah, that's understandable. We'll keep more confusing.
The anger is
like
just going.
on Friday, you were really nice to her and like paid special attention to her. And then you're just like,
Wait,
Well, she's not here, so we-
you
now you're
always
still doing
turn
it.
to
You're
C.
talking to her on the screen.
Hi, everyone. Does du always turn into C?
So then you just put in.
The C is the thing.
Because there's no numbers here, yes, because it's an indefinite integral, I need a c. If there are numbers here, then I would plug those in
And
like
get
whatever.
real in.
And
So
get a
you
real
go back and back? Oh, yeah, never mind.
Okay. All right, so talk to me.
No, wait, hold on. I feel good.
Do ya?
Oh! Ah! What'd you do? Why did you do that?
Okay.
We just
No,
got
wait, hold on.
It's the tooth song.
No, stop. 15 is enough.
Yes, Raina. Good job.
Right then, there, all the guns are
Not 5.
That's the break.
Or Wrigley's.
Bubba, bubba.
I wish it was Bubblicious.
That's because those are bad for you.
Double.
Those are all the bad.
Or fruit stripe gum. That tastes good for about 5 seconds.
I used to.
Is that the zebra one?
Yeah.
Yeah, I used to do that stuff.
Yeah, it's like 10 seconds and then it's done.
My
Okay, we
favorite
good
Or
there?
chiclets.
Yeah.
Chiclets are like.
All right, so this confusing paragraph, just what we've been talking about. The idea behind the substitution rule is to replace a relatively complicated integral by a simpler integral. This is accomplished by changing from the original variable x, to a new variable u that is a function in x, okay? The main challenge in using the substitution rule is to think of an appropriate substitution. You should try to choose u to be some function in the integrand whose differential also occurs. So the reason why we chose x to the 4th plus 2 is because the derivative of x to the 4th is x to the 3rd, and that was in the problem, okay? If that's not possible, try choosing u to be some complicated part of the integrand. Finding the right substitution is a bit of an art. It's not unusual to guess wrong.
Did you say
Get
it's
frustrated.
an art?
Yeah, it's a bit of an art. Okay? If your first guess doesn't work, try another substitution. Okay? So, square root of 2x plus 1.
You.
Right, we want to make that.
Wait a minute.
I'm dumb.
Isn't that something we do in the
No,
beginning?
no, it's not.
No, because there's a 2 in there now. So if it was just the square root of x plus 1, then we could do it really easily just using the power rule, but that 2 screws everything up for us.
Does it really? I think.
Why can't we
You still
use
can't
2x
just
plus
put,
1?
you can't just break this around and put negative 1.
No.
Oh yeah, so we thought that'd be
Right.
That's wrong.
Yeah, because then you have to use the chain rule and you get a different thing. Okay, so Taylor says let's let u equal
But
2x
then
plus
there's
1.
nothing left.
It's okay. What's the derivative? 2 dx, okay? Now Raina says there's nothing left except for this dx, so I need to get this so that it only has a dx in it, so I'm going to divide both sides by 2. So that means that dx equals du over 2. Alright? And so now I have replaced everything in that integral with a function of u instead.
what happened to the square root?
Nothing yet.
There's a whole way of doing that.
So when I rewrite this, I'm going to rewrite it as the square root
I
of
don't
u.
understand why
Why
did you
was
want
the
to
two
make
still
it so
there?
dx equal that?
What, Gabe?
Why is this 2 still there? If we know that, if we substitute u in for 12, why is it 2?
Because now, since the 2 is outside of the square root, I can pull that out and turn this into a very simple integral for me to do. When the 2 is inside of the square root, I couldn't do that. And so that's what I've accomplished by using the new substitution. Yeah, because now we're
So
seeing
you took the derivative of the root there,
Mhm.
that's what that's here.
Yep, yep. Yep, I will wait.
There's the next step to find the antiderivative.
Yep. Next step is to find the antiderivative. Are we supposed to wait? Can we go now?
No.
No.
Why, okay, I don't understand.
Oh, you
Why
just
did you
took out
put
those.
du over q instead of like dx?
There you go.
Yes.
Okay, what's the antiderivative of u to the 1/2? U to the 3/2 over 3/2 plus c, because this is an indefinite integral. And then dividing by 3/2 is the same as multiplying by 2/3.
Is the whole thing, wait, is the whole thing times 1/2 or just
The
that?
whole thing is times 1/2. Well, not the c, I guess. C times 1/2 would just be c.
Or it's not plus C.
Doesn't matter.
Why is
So the 2's cancel. Resubstitute back in there what we chose u to be. And there's my final answer.
Gross.
I guess I don't understand like the order of
Okay, the order of things is to first choose what you want u to be.
yeah.
And then take the derivative of that. And then you have to find a way to make the derivative match what's left in the problem. And so what I mean by what's left in the problem is when we did that u is equal to 2x plus 1, we used up this part of the problem. So all we have left to match is the dx. Yeah, and so that's how come we did that. In this one back here, when we made our substitution, we used up this part of the problem. And what was left was the x cubed and the dx. So I had to get my derivative to match. Okay? All right, so there's more, of course.
Well, wait, I didn't get the rest of the other one. So why can you wait so long to put it?
That's always going to be my last step.
Why?
Because the whole reason for doing this is to simplify it down into an antiderivative that I can do, an integral that I can do. So I do that with my new variable u, and then put the original back
So
in.
after the top part, it makes more sense. Slide, what is that?
Because the antiderivative of u to the 1/2 is, yeah, that's what this symbol means right there.
What symbol?
This symbol. You see
You
that?
had it there too, and then you just.
Well, because I just rewrote the
Yeah,
symbol.
so it's.
But I still have the symbol in both cases, so that is a clue that I haven't done the antiderivative yet. All I'm doing is simplifying the expression. When the symbol, when I go from having the symbol in the problem to not having the symbol in the problem, that means I took the antiderivative in that step. Okay? All right, let's try again. You know what u is. Wait, you know what you are. No, what? What substitution should I make for u? How about 1 minus 4x
That's what I meant. I didn't mean to say over.
All right, so if I let u be 1 minus 4x squared,
I don't want to be.
then that, let me be 1 minus 4x squared, then that means I've used up that right there, okay? So what I need to do is I need to take the derivative, and I need to match that up with what's left in the problem, okay? So the derivative of negative 4x squared is negative 8x dx. Well, I only want an x dx. I have this extra negative 8 there. So I'm going to divide by negative 8. And that tells me that x dx, which is what I have left, is equal to du over negative 8. So now I can rewrite this integral. I'm not solving it yet. I'm just rewriting it as the square root of 1 minus 4x squared becomes the square root of u, right? And the x dx becomes du over negative 8. Because that's the substitution that we chose to make in order to make it an easier integral that we can solve. Yeah, so still not taking the end derivative yet. I'm going to simplify it a little bit more into a problem that I could solve. Oh, because of the 1/8, you mean? Yeah, I mean, kind of there was a 1, you could say this is 1 du the whole time. Yeah. Okay, so now what is the antiderivative of u to the negative 1/2? I add 1 to the exponent, I get u to the 1/2 has to be over 1/2 plus c. Okay? Dividing by 1/2 is the same as times thing by 2, so this is going to be negative 1/8 times 2 u to the 1/2 plus c. Simplify my fraction, put u back in there.
It doesn't have to be 2 times u. Oh, you
Well, I went negative 1/8 times 2 is negative 1.
Can I just put the square root of 1?
Yeah, you could do negative 1/4 square root of 1 minus 4x squared plus.
It sounds like the Wizard of
I know!
when he's in the toilet.
No, well, like, kids at school.
If it runs,
Yeah.
Like, tomorrow.
if it runs.
Have you seen
Have you seen the rivers?
This is pretty cool.
Yeah, they're pretty bad. Obviously.
Dude, you,
I'm not even on this
Is it
stuff.
supposed to be
Their
stronger?
goal wasn't that like,
no, they had a system of 4, 3, 4 lined up.
And nobody who needs to.
Are we on number 3 now?
Yeah.
We had one on Friday, one
They let us
on
out early.
Sunday, kind of? Was it? And then this is number
And
6.
then we get one more tomorrow.
And this sort of floods though.
like when the drain clogs.
No, but one time it flooded so bad when we were like in the grade, and I'm from and the fields.
That haven't gotten there yet.
Right.
That's the highway right there. Oh, that was not
Yeah,
Yeah.
people have at least a power outage.
Yeah.
That's campus school.
Yeah. They make the
Why do you want to get out of school?
Because
It's
I
like
don't want to be
valedictorian.
here, that's why.
They like it down by where it's all sloppy, like by the freeway.
I don't bring that
Yeah,
up
like
again.
over the.
Yeah, grumpiness. I feel like everyone is just grumpy with each other now. They're all gonna hate each other.
I hated all of it in 4 years.
Oh,
Okay, ready? 2 more. 2 more. Ready? Okay, this is an easy one.
It's just winter and no one likes each other.
This is an easy one.
Or is it 5x?
One, yeah, U is going to equal 5x.
I need you to go back to the second one when we're done.
U equals 5x.
I haven't finished anything.
So that means that du equals what?
5.
5
Yeah.
dx. But all I have left is a dx.
You have a cosine here.
Right, so I'm going to, the cosine 5x is now cosine u, and I'm good with that because I know the antiderivative of cosine. Okay? All I need to do is I need to change the dx. So what do I do here?
Divide by 5.
Divide by 5. And so dx equals du over 5. Okay? And so I have rewritten the integral now in a much easier form. Not much easier. Cosine 5x isn't that bad. Yeah, so what's the only simplification I can do with this? Pull the 1/5 out.
Wait, why can't we take the antiderivative of cosine 5x?
Because you can do that, and when we're done with this problem, you should be able to understand how to do that without making the u substitution. There's just like a reverse chain rule in there. So you know how when you take the derivative of cosine 5x, it would be negative sine 5x times 5. Well, what you're going to see here is the antiderivative of
Is
cosine.
divided by 5?
Yeah, instead of being times by 5, it's divided by 5. Yeah, so we're just kind of learning that right now. So the antiderivative of cosine is sine, and the 1/5 is still there, so it's going to be 1/5 sine of u plus c. But then we substitute back in what we wanted u to be from the very beginning, and our final answer is 1/5 sine of 5x plus c. So I don't know if you were listening to Lee in my conversation at all, but you should be able to do these antiderivatives now, these simple ones, without making a u substitution. It's the chain rule backwards.
I can't do that.
So instead of taking the derivative of cosine 5x and then multiplying by 5, you take the antiderivative of cosine 5x and then
Hey, you
divide.
and Dave
I can't
both
even
got
do the chain
haircuts.
rules.
I did what?
You and Dave both got haircuts.
That Gabe got a haircut?
Yeah.
Is there a rule for them?
We got them together.
Noah got a haircut.
It's haircut
They
time.
didn't consult you?
Okay, I don't want to do this one today because that's going to frustrate you. Because it's a little bit, because what you might notice is that if I let u equal what? Yeah, the derivative of x to the 5th is 5x to the 4th, which isn't in here.
So we're
And the
sleeping.
derivative of 1 plus x squared is 2x, which isn't in here either. So you have to do something a little bit more complicated. So let's save that
Can we break
for
up
tomorrow.
x to the 5th though, and then?
Yeah.
Is that what we're gonna do?
Probably.
And then kept walking, I was like, oh, yeah, now I remember.
Oh my gosh, these are actually connected.
She's telling me back.
One minus one.
We have the. That's just all 11.
Oh, it's just the It's a negative
I
one.
was like, that's not
Yeah,
gonna
we're
be
both
together.
doing the same.
Okay.
The answer is negative 11. The answer is negative. That makes sense.
Oh, Aubrey,
Yeah.
I'm waiting for her to post her address so I can write to her, even though she didn't respond to my Facebook message.
I might not, she just texted me.
Ask her why she
We'll
didn't
say,
respond to
oh.
my Facebook message. I even threw in the word majestical, like I thought she would respond for sure.
Yeah, our PD is another version.
Yeah.
She's probably like, you can't just erase that.
This was about.
Sick.
But it was warm. Did they have the Christmas palm trees there? Every In-N-Out burger has little palm trees that are like in an X.
I don't know, this is bad. I don't know burger shirts.
They're not crossed? Oh, I was recording that whole time.